Hi, this is Jeremy James, plant physiologist at the Eastern Oregon Ag Research Center, and I'm here to present an Ag Minute. Anyone that has spent much time in the high desert knows that soil salinity can be a major factor affecting production and the distribution of native plants. Salinity refers to the concentration of soluble salts in the soil, such as calcium chloride or sodium chloride. Because the ability of water to conduct electricity increases as the concentration of salt increases, we can add water to a soil sample, stir it up, and then measure the change in electrical conductivity of the water to determine the soil salinity. Agricultural soils are usually considered saline if the electrical conductivity is greater than 4. As you probably guessed, soil salinity in Harney County is extremely variable, with electrical conductivity in the Harney Basin ranging from less than 1 to over 15. The electrical conductivity of soils in dried lake beds can exceed 50, which is about equal to the salinity of seawater. This week we'll be discussing why high soil salinity is common in arid regions, how salinity affects plant growth, and why species differ in their tolerance to soil salinity. Salts are formed naturally during weathering of rocks and minerals. One reason high soil salinity is common in arid regions is that there is usually not enough precipitation to flush the salt from the upper soil layers, resulting in saline soils. In addition, rapid evaporation of soil moisture can transport salt to the root zone. As a result, saline soils are common in arid regions. But how does salinity affect plant growth? There are 3 major ways that high salinity decreases plant growth. One of the most easily observed ways is that salt can actually cause drought stress in plants, even when soils are irrigated. Water is attracted to areas with high concentrations of minerals and salts. Normally, the concentrations of minerals in the plant is greater than that in the soil water, and therefore water moves freely from the soil into the plant. However, as the salt concentration in the soil increases, water movement into the plant is inhibited. As a result, even if the soil is wet, high levels of salt in the water will not be able to move into the plant, causing drought stress. Yesterday, we learned that one way salinity decreases plant growth is to make soil water less available to plants, resulting in drought stress. However, the specific type of salt, for example sodium, which is found in table salt, can have 2 additional negative effects on plant growth. Sodium can have toxic effects on plants by inhibiting enzyme activity and damaging plant cells. In addition, high concentrations of sodium can cause nutrient deficiencies because they interfere with the ability of the plant to take up essential nutrients from the soil. For example, sodium and potassium have very similar chemical and physical characteristics. As a result, roots of many plants cannot take up potassium or calcium without accidentally allowing some sodium to enter the plant as well. Consequently, as soil sodium increases, plants often become deficient in potassium or calcium. This is one reason adding gypsum, which is mainly calcium, can improve crop growth in saline soils. We have discussed the 3 major ways salinity impacts plant growth. But why are some plants like greasewood able to grow in very saline soils while others cannot? So far this week, we have learned that soil salinity can decrease plant growth by making water less available to the plant, inhibiting enzyme activity, and causing nutrient deficiencies. Some plants, however, are more susceptible to salinity than others. For example, even low amounts of salinity can decrease growth of many crop plants, while some native plants, such as greasewood and saltbush, can grow in soils that have as much salt as seawater. Why do these plants differ so much in their salinity tolerance? All plants accidentally take up some sodium in the process of taking up essential nutrients such as potassium. Salt-sensitive native plants and crop plants try to limit salt damage by using proteins in root cells to pump sodium back out of the plant into the soil. Any sodium that gets past the root cells is stored in the stem. This keeps sodium away from leaves and the growing tips of plants and protects enzymes that are easily damaged by sodium. Unfortunately, the strategy only works at relatively low salinity levels and does not help plants deal with the low water availability caused by salinity. So far this week, we have talked about how salinity affects plant growth and learned that most plants have a few strategies to deal with a little salt in the soil. A specialized group of salt-tolerant plants, such as greasewood and saltbush, can survive in extremely salty soils. One important trait allowing salt-tolerant plants to live in these harsh environments is that they can pump all the sodium that enters the cell into a specialized compartment. Once the sodium is stashed here, it is isolated from the rest of the cell and unable to interfere with enzymes and other biological processes. Because water is attracted by salt, accumulating salts in the cell also allows water to move into the plant more freely. By doing this, salt-tolerant plants avoid the toxic effects of sodium and avoid the drought stress caused by soil salinity. While it is not usually cost-effective to reclaim very saline soils, understanding how native plants tolerate salinity has